So we were having a really, really exciting lecture last Friday that got interrupted. I apologize that the lectures are only 50 minutes. I know it would be nice to have much longer lectures. We started talking about focus and context visualization. And this is related to another very important principle in visual design. So if you imagine you're trying to solve a problem, like you have a client, for example, and they say, can you help us solve our big data problems with your visualizations? And you say, no. You say, of course we can. Your visualization system follows a design principle called the visualization mantra, which means overview first. You provide an overview of the data first. Maybe Dan said this in the visual analytics class.
Yeah.
Then you provide filtering and selection options, and then you provide details on demand. So the focus and context is all about that step 2. Like if the user sees an overview, for example, a tree map, and then they click on a node in the tree map, that becomes the focus. And then maybe they double click on it and they get the details. So this focus and context idea and the visualization mantra are inherently connected to each other. They're very closely associated with each other. Right, so usually the focus is something that we can't predict ahead of time, and so we have to give the user ways to choose what to focus on. And it's very typical that it's through a menu selection or just directly clicking on it with a mouse, something with a mouse. And we looked at this exciting example last time, and actually this was done by a legendary student at Swansea University. So you can actually click on the links and see the video demos of each of these examples. This is from marine biology. Right, the marine biologists are studying wildlife, and they want to understand the behavior of the wildlife when it swims in deep sea. Right? And you can't just follow a cormorant or a turtle or a penguin 1,000 meters under the surface of the ocean. You can't just follow them, right? Because it's too expensive. In some cases, it's impossible, right? And there's that problem, like, imagine you could actually follow a turtle, like in a submarine for a few days. The turtle might notice you're there. And that would affect the turtle's behavior. Right? If anybody can remember the ubiquitous pattern of learning, that fits that exactly. Anyway, so you can see this focus and context principle, where you have the context at the top. The user selects a subset of time that they're very interested in. Then they get the zoomed in view. These are 3 components of an accelerometer vector, which has a direction. And then they get a reconstruction of the accelerometer in a spherical coordinate space. And then we can suddenly understand the animal's behavior. You can watch the whole thing, obviously, when you get a chance. Here's another one. This is a little preview. Focus and context flow visualization. So flow visualization is the study of fluid motion, right, which is a vector field. And streamlines are very commonly used. This is a set of streamlines. Streamlines are curves that are everywhere tangent to the vector field. And then this is the same set of streamlines, but they're clustered by curvature or similarity. Right? So here's a group of very similar streamlines. Here's another group. But the other ones are still there in context. And here's a different cluster, right, that behave a little bit differently than their neighbors, and so on. So these are the focus streamlines, and those are the context streamlines. And you might, I know what you're thinking. You're thinking, wow, that is so cool. Like, can I see that in action? And by golly, you can. Hopefully. Yep. So these are all linked to video demos of the software in action. So that's a streamlined seating rig, or a streamlined seating plane, actually, and those are the streamlines emanating from the plane. And then the user is able to adjust a similarity threshold that says, only show me the streamlines that actually differ significantly from one another, and we eliminate the ones that are very, very similar, right, and don't really provide extra information. And they're being clustered, right? So that's, I won't go into all the details of every video because we don't have time, but that just gives you an idea, right? And you can watch those, obviously, anytime. The rugby example, the rugby glyphs that we've already seen. So every glyph in this visual design is an event in a rugby game. And the focused events are the ones with points scored or tries. Right, so those are highlighted. They're rendered in color. And generally what happens with the context, what happens with the context, it's usually semi-transparent or grayed out. So the focus has full opacity, and the context is semi-transparent, and the colors are dimmed. Sometimes they're just given in gray context data. And this lovely video, also done by a lovely Swansea graduate alumni. This one has a voiceover. So David Chung added his beautiful voice onto this. So when you're looking at it, he's actually narrating what's happening at each step of the process. But that's time on the x-axis. So all the events happen at a certain time, and this is gain on the y-axis. So down here, events have low gain, and up at the top, events have high gain. And you can sort the glyphs by their, for example, by events, right? Kick reception, then restart reception. This is a line out. And we can see, for example, all the points are scored on line out events. You can see that like in 2 seconds. That would be very difficult. Well, it wouldn't be difficult to see if you watched the game, but to make that observation, you need to watch the whole game, which takes a long time. So the focus are the purple halos, and then the rest of the glyphs are providing this context in that example. This is an example we already looked at, but I didn't call it a focus and context example at that time, but it uses focus and context principles. Right, this is the angular histograms example. So basically, that's the same data set as that Ed Grundy used, by the way, in the first example. So it's an alternative view of the exact same data. So in this example, the user can select, for example, click on a bar. Right, and that can serve as the focus. And when they turn on the focus, they can get the original polylines. Right now they're clicking on bars and they're getting more detail. Oh, I see it's left off it started where we left off in some ways. So you can see the user clicking individual bars. and then getting more detail, so the bars get subdivided. Right? And then you can choose them as the focus, right? So the bars that got selected or brushed, right, become the focus, and the angular histograms become the context, or they can become the context, depending on how you set the opacity of your bars and your polylines. This is another focus and context example. We looked at it already, but I didn't use the phrase focus and context. I was sort of waiting, keeping you all in suspense. The focus in this case is whichever node in the graph the user selects, and then the rest turns into context. So there's the demo video. This one also has a voiceover, so if you want to watch it in detail and get a narrated version, then you can do that. Right, so there's the graph, right? And the user can interact with the graph. Right? They can select a node, and then the node becomes the focus. Right? And they can zoom in on the graph and see the traffic or the frequency of transitions from one node to the other. At some point, he does actually click on one of those nodes and interact with it. There it is. Okay, and there he clicks on, so there's the interaction with the actual nodes. By the way, this is the same context view that was in the first video. It's just, there's the three components of acceleration, X, Y, and Z, shown in a time series plot. So it's actually the same thing, it just looks different. Here's another FlowViz example. This is fun too, because I saved this for last because it almost summarizes, in some ways, it's like a summary of all the things we talked about already and a preview of things to come. So this is a FlowViz example. So in this example, the focus is a slice of the flow volume. Can everybody see there's a grid here? So the user has chosen to slice to this 3D volume that's reflected by this grid. And then place vector glyphs at the center of every grid cell. Some of them are hard to see because the color choice is not ideal. And the vector glyphs are very small. And then the context is this geometry. Right, the geometry, so the flow is coming into this block and it's coming down these two pipes, right, into a combustion chamber, which you can't see. So it's from automotive simulation. And you can see a demo of that too, of what that looks like in you know, when somebody's actually using the software. Right? This is commercial software too. This is not just a toy. It's a piece of commercial software. Right? So that's the focus there, and then the user is sliding the grid through the geometry. Right? The geometry serves as the context. That looks a little bit funky, actually. Looks a little bit different. That's the idea. So the user can translate the grid through the volume. They can rotate the grid any direction they want, and they can They can change it to a polar grid, for example, and they can alter the resolution of the grid, right? How many grid cells there are, right? There's another kind of focus and context visualization that we're going to talk more about when we get to the flow-viz part of the module. This is a visualization of flow at the surface using vector glyphs. This is the same data, but visualized using texture. And then we have a focus and context version. So the focus are these streamlines that connect critical points, and then the texture serves as context information. So it's a flow is focus and context style. These connections are also called the flow topology. No video with that one. Here's a flow-viz example. Anybody remember what that is, that object? We did mention that already, didn't we? What this object is? Or am I hallucinating? Was that a different class? No, we didn't mention this shape yet. Everybody saw the attendance register? Anybody know what that shape is? I must be hallucinating. I guess I'm getting confused with a different class that I taught.
Is that engine?
It's an engine component. Any idea which one? There are pistons inside, but they're not shown here. They're not actually shown. Any gear heads in the room? There are no gear heads, like people that like to work on cars or stuff like that, or just open the hood and see how things work or something like that. If we're, fingers crossed, the combustion engine will just disappear. Right? The combustion engine is a disaster in lots of ways. This is from the combustion engine. Nobody opens the hood and looks at how a car works or something like that, or has older brothers. I had an older brother that is very, very good at fixing cars, and we would call him, he would definitely classify as a gearhead. I think gearhead is the word. Isn't that the one? Yeah. And my dad as well loved to work on cars. That's why I'm so bad at cars, because they would take the tools away. If I tried to fix anything, they'd be like, you don't know what you're doing, you just grab the tools. This is a cooling jacket. So one of the problems with combustion engines is heat. Right? Most of the energy is just is converted from potential chemical energy into heat, which we don't even want. Right? More of that energy is converted into heat than to kinetic energy, which is what we actually want. Anyways, that's a cooling jacket. So the geometry serves as the context of this example, and then this stream surface is the focus, so that's reflecting the properties of the flow as it traverses the cooling jacket. Right, the cooling jacket is supposed to keep your engine from overheating. Anybody ever had their engine overheat before? I'm the only one? Oh, lucky people. And there is a video for that one, it's a good one. Lots of motion today, not just static slides. Right, that's what the flow of the surface of a cooling jacket looks like. It's showing up a little bit, okay, that's a little bit better. It started out a little bit blurry due to compression artifacts. Right, that's a close-up view of one of the heads, the combustion chamber heads. Right, so there's that example. So the context is the geometry, the surface geometry, the cooling jacket. You can see it's a very complicated piece of geometry or piece of the engine. And then the user has seeded two stream surfaces. So stream surfaces are surfaces that are everywhere tangent to the flow. We're going to talk a little bit more about those in the flow as part of the module. That's the idea there. Here's a completely different kind of, well, it's not that much different, but it's another scientific visualization view. This is a focus and context foam visualization. In some ways very niche. You won't see many people that have studied this. But this is studying the behavior of foam at the bubble scale or the bubble level. So simulating the behavior of individual bubbles as they get pushed through some sort of geometry. And in this example, these bubbles are the focus, and then the gray ones, the skeletonized ones, are the context. And I guess it would be impossible to say like what those focus bubbles are. But those focus bubbles are the focus where the topology of the foam changes. So when one bubble slides past another and its neighbors change, the topology of the foam changes, and then it gets highlighted in this focus and context visualization. This is a 2D time-dependent version, and this is the 3D time-dependent version as the foam descends. And there is a demo video of that one too. If you're interested in watching these examples in action and seeing them in more detail. Slides are not that exciting, are they? But as soon as things start to move, it's like they're alive. They really exist somehow. More interesting. Motion is more interesting than static slides. And you could see some, so that's an example of the foam topology changing. So the neighbors changed. It was a little bit fast, but you can see the idea there. Okay, everybody think they understand the idea behind focus and context visualization? Hopefully. Good.
I have a question.
Carlo?
Do you make a distinction between overview plus details and focus plus context, or are they more or less the same in this visualization?
Did everybody hear Carlo's question? Do you want us to say a little louder, Carlo?
I just asked if you make any differentiation between focus plus context and overview plus detail for the course.
So Carlo asked, is there a distinction between focus and context and overview plus detail? I would say that they're inherently related to each other, but I wouldn't say they're equivalent. So focus and context is explicitly deciding that one subset of the data is more important than the other, and putting it in focus. Overview plus detail is not making that explicit determination. It's providing an overview, but it doesn't necessarily say make the overview the context. Just it's like more general than focus and context. Yeah, focus and context is like an enhancement of the overview and detail plus detail. It's like an enhanced version of that idea. And if anybody's having trouble sleeping at night, there's some extra reading, but this is just in case you want to know where those examples actually come from, and you can find out where they come from. Good. Any other questions about focus and context?